At Adyen, connection is everything. It's how we build momentum with our people, customers, and product. One financial technology platform.
Ok.
Perdón.
Nada. Cosas de director.
Bueno, le has dado a esto, pero aquí no. Y es que lo que creo que, o sea, claro, lo que has tocado antes, desarlo. Porque no se está escuchando nada de Zoom. El Zoom está conectado a tu ordenador.
Lo he bloqueado esto.
Sí, es bloqueado. Creo que ya está, espera.
No te estoy oyendo.
Sí. A ver, ya. Y le das aquí.
At Adyen, connection is everything.
Sí, es que queremos que...
We had an IPO in 2018, which means that our shares went public. We have the bank license in Europe and UK banking authorization and the branch license in the US. We basically provide end-to-end payment capabilities, data-driven insights, and financial products, all in a single global solution. We have over 4,000 employees worldwide, and we are present in 29 global offices. And we dedicate 1% of our net revenue annually to sustainability initiatives, such as the UN sustainability initiatives. We have a global reach because we have merchants all across the globe, but we also have local expertise because we support local payment methods and we tailor solution to local regulations. And we have enterprise support because most of our customers are from mid-sized to large companies. We like to simplify things for our customers. So we are one partner that provides a single platform and a single integration for all of them. Beyond payments, we like to think of ourselves as a subscription to innovation because we are aware of the latest technical developments and we try to implement those for our customers. So just to let you know a bit about here, the location in Madrid. It was created in 2014 and it first started just as a commercial office. But 4 years ago, we decided to expand it to also a tech hub. We have 30 employees at the time in Madrid, and now 4 years later, we are over 200 employees. And in fact, we grew so much that we have to move to a different location, which is this office, that now has around 1 year. It has 8 floors. We will later invite you to the 8th floor, which has a canteen. So yeah, terrace. And as a global terrace, from here in Madrid, we provide solutions to clients across Spain, Portugal, and beyond. We also have a few open roles at the moment, like Java software engineer, implementation engineer, AML and scale investigator, IT support engineer and account manager. Marta is our tech recruitment partner, so if you are interested, feel free to reach out to her later. These are some of the clients that we are working with. As you can see, most of them are big names like Spotify, Booking.com, Zara, H&M, and so on. And since this is a data conference, I also wanted to give you some insights into the data things that we have in Madrid. One of them is the AI research engineering team, which is the one that I belong to. And our main focus is basically to apply GenAI cabinet research innovation into practical business applications. Then we have the GenAI platform team, which what they do is they provide a GenAI platform to make it easy for other teams to create GenAI applications. They are the people that are going to speak later after us. We also have a feature platform team. What they do is they provide an easy way for machine learning models to use features. And then we have an AML tech team that we have recently created and that we are going to, it is going to be focused on applying GenAI tooling for alert generation and basically reducing the time of AML investigations. So to start with the first talk, we are going to tell you a little bit about the lessons from the experimentations in applications. So what we did when applying GenAI to KYC processes. For those of you who don't know about it, KYC means know your customer, which basically means that when a new merchant joins Alien, we have some processes through which we try to know a little bit more about them to assess like the risk and if we would like to have them into the platform or not. First, I'm going to tell you a little bit of our team in general. So basically, our goal is to bridge the gap between cutting-edge research and tangible business value. Basically, if you think about the different projects that you may have, you may think about them in an exploration versus exploitation spectrum. So on the left side, for example, you have pure research projects. So those will be, for example, like building LLM from scratch, for example. And then you have exploitation focused projects. So those would be, for example, the ones in which you already have a mature technology and you are sure that you can apply it to create like tangible business value. So basically, our team lies a bit in the middle between those. So we try to bring pure research solutions, so cutting edge research from the left of the spectrum to the right of the spectrum. We are these people in the team. We are currently more than 10 people. We are growing quite fast. I want to tell you a little bit about our core principles because yeah, we have quite a unique setup. So we were thinking hard about like what type of setups, what type of principles should we have to apply cutting-edge research to projects that can end up in production. So, for example, one of the things that we do is we partner with domain experts because there are teams at Alien that have already been working on certain areas for a long time, so they know more about us, about the particular business problem. So we partner with them in these projects. We also start like from the left of the spectrum to the right. So we like to validate ideas quickly. And then once that an idea is validated, that is the moment in which we hand over the project to the domain team. We also have some processes in mind to have regular reviews with the stakeholders. So basically, this is the reviews in which we decide where the project should go. We should pivot in the strategy or we should kill it. Because since these are research projects, there is a chance that they may go wrong. We also like to have controlled exploration, but even if we are applying research, we want for the experiments to have a business impact, right? So we need to prioritize the experiments that we think are going to have the highest business impact. We also, every time that we define an experiment, we try to define how we are going to measure it. So like, how are we going to decide if the experiment has been successful or not? And also, we like to identify the spillover impact. So even though that some project might not be successful, we may have learned some things along the way that perhaps will end up in the GenAI platform team, and maybe they can be the component out of it, or maybe it could have some application in some other project, even though if this one didn't succeed specifically. And in terms of our projects, we currently have 4 initiatives. One of them is a foundational model. So basically, at Alien, we are processing a lot of payments, as you could see from the revenue that we had last year. And since we have so much data, we are interested in trying to train transformer-like models with those historical payments to try to see if we can learn useful representations from those. So, for example, embedding like representations that perhaps we use for downstream tasks in other type of problems. We are also interested in AI agents. We think that they could have quite impactful applications, but so far we are seeing that sometimes these agents struggle to succeed in real world tasks. So one of the things that we did is we partnered with Having Face, and we developed a benchmark for AI agents in collaboration with them that you can actually find in the web page. There are companies like Google that have tried the AI agents with this benchmark, and they are getting better and better results, but they are still far from solving these tasks successfully. We are also building GenAI agents to try to aid with the investigations of anti-money laundering. We are also applying GenAI to KYC screening, which is basically the process that we follow to assess the risk of our merchants, and that is the project that Jorge is going to tell you a bit more about now.
Thank you, Sergio. Well, hello everyone, welcome to the Alien domain. I'm going to present, yeah, thanks. Let me just put everything in place before. Okay. So yeah, we're going to talk about the screening process, which is part of the requirements we as a national platform, we are we have to comply with some legislation. So it's one of the things that we have to follow, which is part of the KYC process, which stands for know your customer. And as you can see here, what the screening process does, even though it might sound like a little bit boring because compliance is important for most of the people, it's something which boils down to something very easy. Okay? So we have to answer the question, does the customer post any risks to our financial platform? So we have merchants and merchants who actually log into the platform and we have to think about them and we have to know if they can post any risks. If they can deceive us into the platform and into some kind of issues in terms of financial procedures, right? So how the process works is that the new customer, like you can see there, logs for instance into the platform, and that's where the KYC process starts. And one of the processes I told you is the screening process. So we have a set of watch lists, which is basically a list related to institutions, which provides list information on people that we have to be worried about. And what we have to do is basically answer the question, is the new customer actually one of these people we post or is the company? Yes, that is a match, or not, it's not a match. It boils down to something which is called entity resolution, right? First, that's another. Sorry, sorted. So, well, I don't want you to go cross-eyed in this slide, but we prefer to go from top to bottom here. So we're going to start from the top, which is architecture. So you can see there in the bottom in green, we have like the main process that we have built in order to provide a solution to this problem using generative AI. So the first one you can see is that when from HTML, we get the identity data that is from both the new customer as well as the profile, and we have to check against. And what you see here in that box there, I don't know if I can points, maybe not, but in the screen and the pipeline, we have built a face API application, which as you can see there, it makes requests to GenAI throughout our self-hosted GenAI gateway, which is going to be presented by our colleagues here, by the GenAI backend team, in order to resolve all return steps, provide two outcomes, which you see here, okay? One of them is the resolution, that is what I told you before, is that match or not, that is both the match person or not. And of course, we have to validate what the model has taught throughout the process, so we have to give each of the modules or steps reasons, right? The idea is that we don't automate this 100%. It's actually shown to the user, to the screen analyst in this case, in order for them to go faster and actually get some insights before going to the actual process, right? Actual investigation. Something that I haven't talked about that you see in the top, just for those of you who are curious, is that we have created some events and dashboard visualizations in order to monitor what's happening in the application, as well as something interesting if you work with LLM models, is that you can actually have a higher level of observability using LLM tracing, which is supported with NumFOCUS, which is also provided, and I'm going to precise for it for what's going to be presented by the platform guys here, okay? So I'm not going to go into that, but it's something that you might consider for your projects. So I'm going to dive into what's inside that box, the SQL pipeline, which I think that all of us are curious about. So this is what we have built for the project, high level again, but we don't want to go too much into detail because of time constraints. As you can see there, we have different steps. So the first one is basically looking for other information through the internet for both profiles, that is both the new customer as well as the profile that we have to check against in order to have better insights and assess whether they're the same person or not. And after that, what we actually do is we apply some business guidelines or rules, because not every profile that is on the watch list, which is like a general watch list, actually has to be checked. There are some of them which not pose a threat to our financial platform, so we don't keep on going with the process. And if we have to keep going with the process, we use the rich information and we actually check if they're the same person or not, what I showed you before, which is what we call the entity matching module. Okay. So one curious thing, as well as one of the reasons why I believe that this process has been a success, is because by the nature of the problem, which is entity resolution, as I talked about, we had to twofold evaluation, right? So yeah, of course, for most of the applications, you have like a reasoning part, which the problem is that it takes time. You have to really with the lemmas as judge or getting back to the humans for human feedback. But in this case, as you can see, the outcome of the whole process is actually a binary label, right? Which is match and unmatch. So we got advantage of that. Sorry, we got advantage of that, and we actually can use classification metrics as some kind of proxy to know how the model is doing without checking the reasoning itself, right? So let me see how I'm doing with time, just in case. Okay, not so well. So if you can see that for the outcome, for the binary outcome, the good thing is that we can extract how the model is doing through the whole pipeline, but as well as you can see the metrics for each of the modules. So we can see which model is not performing so well, and actually tackle or try to prove or see what's happening in that module. Which is that it's, like I said, it's very fast. It's just executing so code instead of getting back to people. And yeah, I'm going to explain which we think that Serge and I, which have been working on this project, think is interesting, which is the enriched information part. I don't know how much of you know about Gemini's ground search. It's a capability provided by Gemini, which is like some kind of tool to allow the Gemini to actually access the web and extract information that we think that is important, right? Or we can extract. Which becomes very handy to our project, right? Which is exactly what we want to do. So if you use an example, we have like a risk profile. As you can see, we have to different data points in order to identify the person, such as, for example, the name or other data, right? So imagine that we're missing other important information. So what we do is we use ground search, as I told you, and this is how it works. So first ground search from your query, for your prompt, generates a query generation that is different search that is going to go through the web, and it's going to output two things. First, a report, like some kind of investigation of the findings that he did from those web searches, as well as something very important, which is the grounding checks, which allows inline citations in order for you to know actually which kind of piece of data has been extracted from which source, which is actually very important in terms of compliance for our whole process, right? So this is how it looks like after we end up processing it. We actually added a new module in order to extract what has been extracted from both, from the report and the run chance. So we start the reasoning of the model, the value that is found, its citation, that's those URLs. But something that we want you to know is that we found that the data that I found is not so reliable. Sometimes it use data or it finds information from wrong sources or not so trustworthy sources. So we asked the LLM to actually provide like a confidence rating in order to filter that out. So that's one of the recommendations that we found out on that process. I don't feel like I have the time to explain this right now, but basically what we did is, in this part, we use LLM as a judge in order to assess how well the OSINT was doing. And in here you can see in green, if the model found the same thing as the analysts were finding, in this case, if it actually extended information, if it added more information, and this one is in the cases in which you can find some information. But as you can see, most of the cases is performing very well. And finally, I'm going to go very quickly over the link matching. What we're doing here is basically what I told you, trying to identify the new customer and the risk profile of the same person. So let me put you with an example. This is, for example, one data point. You have the new customer with the John A. Doe as name, and then you have the risk profile with the name as John Anderson Doe. So as you can see, you can put some custom rules to the prompts in here in order, for example, tell them to consider persons with variations on the name as matches. And as you can see, the LLM is actually going to provide an output for that. And what's very interesting here is that you cannot apply traditional LLM or programming techniques in order to derive this. So it's a task that is well done by actually the model itself, right? Yeah, to finish, so we do this for different data points, several data points, not only the name, but also other ones. And we extract from each of them the reasoning and the outcome, that is, if the model thinks that data point belongs to the same person or not. And then we make an additional call in order to see, for it to decide if actually the right person or not, right? So at the end, the output, if this is the output of the pipeline, it decides whether it's a match or a mismatch. It's good enough. We have questions afterwards, but I'm having more time, so I'm going to the to the documents.
So some context for some of you. We work in a quite complex or special setup. We have many distributed Kubernetes clusters. They are all on-premise. We don't rely on public cloud. And we work with GitOps best practices. So everything is defined in code, and the platform architecture is deployed based on that. We have, of course, for the GPUs, we rely on NVIDIA so that we can host the LLMs. So we're going to talk today about all these different core components. We have on one side the LLM inference for model serving. We have the LLMs framework. We will also talk about knowledge bases, how to use the model's context, and how to add observability, as Jorge previously said, the NumFOCUS, how to unify all this with a gateway, and finally, how to allow LLMs to use tools and servers. So here you can see a summarized overview of the architecture, what it looks like. We have on the side the users, could be applications, could be developer laptops, or whatever, and they will reach the GenAI platform in the middle, and they will target different models, both on-premise, but also cloud hosted, such as the GenAI API that we've seen before. We will also allow these applications to have additional observability with NumFOCUS and to connect to different MCP servers and tools. We will go now one by one to describe this. So let's start with the LLM inference. So we have an issue here is that LLMs are quite big models. We have huge models that have from millions to billions of parameters. These are GPU memory hungry. And we need some kind of framework or tool that is efficient in the sense that these model weights can be loaded into GPUs and serve requests with an API. We also have many different LLM architectures that may differ. Some architectures expect one input output schema, different prompt templates, different vocabulary. While also, if the model is so big that it doesn't fit in a single GPU, this happens with big models such as DeepSeek-1, which needs a handful of GPUs to work. And also how to deal with some intrinsicies of the LLMs with tools such as KV caching or optimization. For this, we have used VLLM, which is an open source, high throughput and memory efficient LLM serving engine, and it's been working quite well so far.
Okay, the next component we created into the platform was the LLM apps framework. So the first thing that was ready was the LLM inference. So now we have models, but the next step is to deploy applications that will be using these models, right? So this framework allows developers to self-service their own applications. So it is a monorepo with that allows people to deploy fast API apps. And this fast API, the time in a second, I forgot about it. Oh, now so yeah, as I said, it allows developers to build fast API applications. But we also build it in a way that after some time, so it is able to use these apps with different frameworks. So the thing is, you can use LLM frameworks like LangChain or Llama Index, or just not use it at all and just use, for example, the OpenAI SDK or just normal requests. Right? So with this framework, what we allow people to just streamline also the deployment. So the 3 steps that people do, the developers, is code the application, then build these containers, then and then later will be deployed into Unity just a few lines of code. Okay, so so now that we have the LLM inference and the applications, the next step that we saw that we needed is add knowledge bases to these models, because the models were not trained with Alien data, because we are using just open source models that we download from Hugging Face, or third-party LLMs like Gemini, as they just said in the screening presentation. Right. So what we built is, as I said, a system for embedding this internal context into the models. So we managed to build a system that offers a hybrid search because we realized that the vector search was not enough for certain use cases. So the search that we are doing does both and reruns the results. Also, we couple the indexing and withdrawal logic because that way it allows us to deploy reproducible sources that if someone needs to do it, they can evaluate easily that way. And the backend we used for this search is Elastic. Although we started with pgvector, but we quickly realized that the pgvector was not enough because of their vector dimensionality that it offers when you are indexing with NHNSW, which is the algorithm you normally use for this kind of search, the vector one. And also, it is not really suited for keyword search. So here you can see a diagram of this system. So this blue thing, the big one in the middle, is what people deploy, like the logic for both indexing and searching. So here in the top, you can see that we'll put certain documents, like the knowledge base to index into S3, and it will be picked by the indexing job, which generates the embeddings, and will generate an index into Elastic. Then the search API, it is going to be handling the user requests, and retrieving this information from Elastic, and then returning the result that the user needs. So this is it on the managed knowledge bases system.
So we've been adding here different components, the inference on one side, the applications on the other, knowledge bases. Now everything seems to start adding more complexity, and for this we need some kind of observability too. So in this case, we know that LLMs by default are quite tough to debug. Sometimes we need to make sure of the input, the outputs, which tools are they using, which kind of context is being fed to the models. So observability here is a key factor. We have chosen NumFOCUS as an open source observability tool, which is quite popular, and it allows us to self-host it in our own environment. We know NumFOCUS has a cloud public offering, but we can self-host it as well in Kubernetes. So this allows us to receive and store traces of the different models, as they explained before, and keep track of the scores, see how our applications evolve over time in terms of latency, but also in terms of different scoring, and also allows us to do data experimentation, prompt experimentation, etc. One key thing for choosing NumFOCUS here as well is that it has many different SDK integrations, so applications can easily use NumFOCUS OpenAI or NumFOCUS LangChain Llama Index iterations to replace 2 or 3 lines of code and usually add this tracing to the app. So it's a really, really good tool. So finally, we need to unify everything in such a way that we can have different models, different applications talking to the models, knowledge bases, and observability platform, but giving some kind of unified experience. For this, we need some developer-friendly OpenAI API-compatible system that it's good that if it offers a UI, then that's good. So think about us our adding internals OpenAI platform. We would also need to unify all these BLM self-hosted models, but also being able to route requests to external models, in this case through GenAI API. So we have a hybrid platform. We also need to do it in a secure and easy access way, so that we have many different distributed Kubernetes clusters. We have also a lot of restrictions in security terms, so that these requests are handled in an effective way. So we need some component that allows us this. Finally, we need, we love platform, people love meetups, so we need some configurable behavior via code if possible. So we can control role-based access control, rate limits, budgets, caching, automated feedback. And for this, we have chosen another open source tool supplies called LightLM, and more specifically LightLM proxy. This can be self-hosted in Kubernetes, and it's a proxy server that allows us to unify all the different components that we have mentioned.
Yes, and after this component, the platform gateway, the next thing that we are experimenting with and learning more about, because it unlocks very cool use cases, is this concept of tools and MCPs. Okay. So tools and MCPs are allow LLM apps to be a bit more complex and potentially resolve more open-ended problems, right? So instead of just passing context to the LLM and the LLM dealing with it, you give the LLMs, aside from the question that you are telling it, you give it different tools that it will be able to use to support the user's need the best way it can be considered. It can consider possible. So here in the left, you can see a very simple example of the simplest agent loop. It is just an LLM calling these tools and then deciding what to do next. This thing can be much more complex, like then inspecting what is the how this output affects the environment and stuff like that. But this is the simplest. And in order to use tools, there are different ways. So one of these is the model context protocol, which what it does is provides a standard interface. Well, it's a protocol for basically interacting with these tools in a more easy way. And this way of handling tools is very good, especially when you want to generalize a particular function. So let's say that you have a tool that might be used by many different LLM applications. In that way, in this system, you would want to use model context protocol. But really, also you can use simple functions of Python or the language that you are using in your LLM application. And because of that, you can just parse the output of the LLM, which decides which tool to use, and then call the tools. Because really, both of these are transparent to the LLM because it doesn't really know what protocol or which way this tool gets executed. It just helps with the coding really for the developer. So some examples of tools that we have and that you can create as well that are very interesting. For example, there are MCPs for interacting with Spark. So we are experimenting with the Spark history server, which allows you to query Spark to see which jobs are there and the output of them. So it will help people debug their Spark applications. Then also you can very easily add tools on top of an OpenAPI spec. So really you just can compare an API to a tool that an LLM can use. Just be careful because, at least start with read-only tools, and then you will be able to see, if you can do some right stuff, because of course it can be dangerous if not managed correctly. And another thing that we are using a lot is helping plenty people inside the company is to just interact with these tools, using these tools to interact with the alien internal documentation. Then ways you can deploy this thing is, for example, you can deploy a companion MCP server along with your system, or embed this kind of server inside your application just as another endpoint, or just build your own custom MCP from scratch, which you can very easily do with the SDK. Okay, and now that we explained this, all of these core components of the GenAI platform, this is the final result as we already showed you. So just to put everything back together very quickly, because I want to leave some space for questions. What people will do is deploy their applications here. So there in the left, you can see the clients. So the developer will use the GenAI platform UI to see which models are available and also the different tools that are available, because these tools are available in the platform as well. So very easy to see and discover. So then to the application, when it is making when you are building your application, you will put your question and also select which model do you want, because you can just change the model with the model main parameter with the different frameworks, because everything is OpenAI compatible, and it is abstracting the fact that there are there can be many different providers for this LLM. And then you specify the tools that your application will use, and then the model will see, based on the query, if it needs to use the tools or not, and what to do, right? So yeah, this is it on the GenAI platform, and thank you for being here.
For questions?
Yeah, absolutely. We take questions in English and Spanish.
Yeah. I was interested in UI NumFOCUS for observability, and I was interested in knowing a little bit more about what kind of, you were talking about scoring, and also latency, that there are issues. So how do you get that scoring? Do you have any kind of user feedback for that?
Good question. So essentially in NumFOCUS, you have many kind to provide the evaluation of feedback for your applications, and you have an SDK or an API that you can query for NumFOCUS and associate a given trace or set of interactions of your application to a given feedback. So this is the way that NumFOCUS understands, this interaction of a user or an application that is composed on tool calls and input, output, etc., has this scoring associated to it. This could be user-provided feedback. So if in your application you have like a thumbs up or thumbs down button, for example, you can integrate that with pushing that button, the query, the trace ID is linked to that feedback, and then later in NumFOCUS you are able to see the score associated to that. But you can also have, for example, LLM as a judge pipelines, so that you have automated evaluation of all the traces that you have. And then you can define like a set of automated score, like correctness, toxicity, and things like that. And this is like at a server level. These are like the kind of ways of evaluating.
Thank you for the talk. I was very interested in the matching project you talked about. I wonder at what point do you actually do this investigation of the customers? Is something you do when the customer enrolls in the bank, or do you do it every time it does a transaction? Because it seems like an expensive procedure to do it every time, right?
Yeah.
Okay. Yeah, that's a very good question, actually. As the name states, the screen is part of the KYC process, so it's like know your customer. So it's part of the due diligence that we have to do once we're onboarding a customer into the platform. So every time that a new customer comes into the platform, we have to check against all the profiles, risk profiles that we have in the watch lists. I think that there's also another, but we haven't worked on that. We have just worked on that pipeline, but I think that the screening team also works on at transaction level. So I think I'm not too knowledgeable of that, but just for you to be aware of, most of the pipeline focuses on when they're onboarding only, but there's also checks that are being done on the on the screening level, transaction level. So yeah, I don't know if I answer your question or.
Look, from the explanation, I saw most of the database analytics can be put on tables, and you're making binary decision. So you focus the file. Why LLMs?
Yeah, that's a good question. If we go back to the slide that it's just that I had to go so quickly, and I don't think I actually explained it properly. Apologies for that. So what I wanted you to see in this slide actually is why we relying on LLM models instead of traditional programming and traditional machine learning. And as you can see here, for example, it's a good example. You can see here 2 name variations, and you actually have to understand the language to know that they're actually variations of the same name, right? So you need the model that you're using to understand the language in order to derive that John A. Doe is actually could be a variation of John Anderson Doe. So of course, if that happens, if you put a rule here, considering variation as much, the model is able to infer that. That's not so easy for traditional programming or machine learning techniques. This is one of the examples. We have many other data points, and most of them, if not all of them, actually rely on this kind of logical thinking based on language.
I have a very short second question. You mentioned that Jim is pulling information from the web about the user, the version.
Yeah, essentially what we have here, yeah.
There is all sorts of stuff in the internet. How to verify that the data that is pulling is actually legal, for example? It's not English around data privacy, it's a different legal place where you are operating. How do you manage that?
But do you mean legal from the admin perspective or legal from the, the gen?
Different countries, different legislations, different laws regarding
Yeah.
privacy, putting data from the internet, potentially anywhere.
Yeah.
You may not be able to use legal data in your system where you are operating. So how do you?
Yeah, I think that there's 2 dimensions for that. I don't know if you want to share that one, Sergio. But I will complement what Sergio is going to say. It's just that I also want to.
Yeah, I mean, for that, we do have like list of the web pages that we trust. So like we started this process by understanding how this is done manually. And then we try to take that to an automated level. So we do have like quite list of like official governmental sources and this type of thing. So we filter that information on that type of level, yeah.
Well, what I wanted to say, maybe while we look for another question, is that we also take care of that implicitly in the confidence score kind of thing that we did. So in that rule, we also imply that it has to rely on well-trusted sources instead of any kind of web page is out there. And we also rely kind of on Google, which knows all this kind of stuff sometimes in order to be able to retrieve the trustworthy web pages.
Sorry, like in the program, what I remember now is like there is like even an instruction that it has to have like 3 sources that we trust in order for us to really trust our data points. So like we went through like all sort of rules to ensure that the information that we are pulling is really like something that we can trust.
We have time for one more question. I can actually take that. Sorry. You're operating everything yourselves on Kubernetes, on premise. Can you comment on like what's the experience of operating that? Because I think it's very unusual in general to be operating that much open source software. So anything.
Our experience, I think, is that it is very good because actually you learn much more because you touch the systems at a much deeper level than, for example, if you are just using APIs. Because then you can understand how the models behave, how you can deploy them, how you can do things. So yeah, it's very good.
Also, for like let's say a security perspective, this infrastructure has been around for quite a long time, and there's a lot of platform engineers that have like wide knowledge on the security standards for the banking APIs, etc. So it was a decision took that everything has to be on-prem and under a system that we already control versus going to a public cloud offering that added additional layering of legality. We have to take into account many different other levels. So also it's for one side the open source solutions and the Kubernetes aspect, but also like the legal standpoint and the security principles that govern a bank, let's say.
Amazing, thank you. I think there was appetite for more questions, but if you folks will stay for the peers afterwards, then I'm sure they'll be happy to answer. So another round of applause, please. And now for the next talk of the evening, Bojan is going to tell us about electrical interpret right for interpretable machine learning. So slides. Thank you. Good evening. So here's some echo. I don't know about you. Yeah. Micro. Okay. 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 Good. So I'm actually not really going to talk much about the library. I'm going to talk about the practical machine learning a bit more in general. So I'm from the Universidad Politécnica in Madrid, from the Department of Artificial Intelligence, which hasn't been just created now in the middle of the boom or renamed. It's been called that way for decades now. So what I'm going to talk about isn't really what I work a lot in. I do some related research, but it's mainly content that I teach. So this is at the master's in artificial intelligence and also at the summer school that we have. And the courses are really popular. So yeah, I realize people are really interested in this topic. And I also realize that they're interested because they want to know what, say, we talk about traditional machine learning and tabular data, not talking, say, about LLMs. People are interested in black boxes, right? And I'm going to be talking about something else today. So they really want to know how can they understand what their neural network is doing or their random forest is doing and so on. So the thing is that there's also this kind of well, let's say reflex, right? If you have a problem, I'm just going to use whatever is kind of the most powerful model, let's say, right? So, and it also kind of, there's an implicit assumption that if you use something that's interpretable, it's not going to work well. So there's like this notion of a trade-off, which, yeah, we have here one of those typical kind of graphics that you may see kind of with the interpretable models here in the bottom and say less interpretable ones more accurate, right? So, but there's, of course, this is not universally true, of course, cannot be, and sometimes you can kind of get both things. You can get something as, or results as good as with the black box using, say, a glass box model. So that's what I'm going to talk about today. And also, finally, the performance that you might get. So accuracy is not the end of the story. So there's other aspects that you might want to care about. So that's also something that's kind of easier to think about if you have an interpretable model. So there's, of course, claim that you can get like both things. I'm going to cherry pick a few examples. So one is, so for example, this is from a challenge for predicting the risk of credit default. So actually here, Well, people tried series of different models. Nothing could outperform some of these simpler models, which were interpretable, right? Such as even a logistic regression, or something that I'll talk about now, which is a sort of a custom model that the people built, right? So this custom model is really, it's actually like a neural network, but it's not dense, it's not fully connected. The features are meaningful, so that's one thing. You can actually understand what they are. They have to do with the person's like financial background. But then, for example, the connections here are meaningful. So, for example, the only nodes or kind of variables that connect into this, let's say, neuron, they're all semantically related. So they're kind of this second layer. The neurons are also kind of interpretable. So these, let's say, have to do with, let's say, past transactions, and these have to do with whatever. So there's a couple of things kind of to note here. So first is that, yeah, of course, as I said, they can be a reflex. I just do the easiest thing and train a boosting assemble that's going to work fine, quite probably. But I'm going to have the interpretability problem. So maybe it can pay off to kind of try to think a bit hard about what actually is going on, and I can actually get, again, both things in some cases, right? This is another example in kind of a medical domain, predicting the probability of death for pneumonia patients. And again, a similar story. The models that were used here, and I'll talk about them a bit more, are additive models. And again, it's not like some toy data set. It's a huge data set with many features, and was very fascinating to collect it. This was kind of a serious study behind this, not just somebody kind of toying around a bit. And there's also kind of recent empirical studies comparing a bit. So, for example, so these kind of here, you can see kind of this supposed, right, kind of trade-off. And in dark dots, there are like actual results. So, for example, this is an additive model, which is interpretable. As I said, I'll say something about it. And it's not really doing poorly. It's actually kind of almost right there at the top. And actually, often, you can get a good percentage, say, of the performance of the best model with a simple one. So maybe, let's say, the best model is, I don't know, right, 90% of the time in classification, and a simple model 80% of the time. So perhaps, but that additional gain, well, maybe sometimes not necessarily worth it. So what problems are there with black boxes? So first, we can't completely understand what they're doing. So that's perhaps the bigger thing, right? So we can try to explain them. We get various importance measures. We get different things. The thing is that this explanation is different from the model, and they're not always going to coincide. So, of course, if you're doing something very sensitive, that differences can be very problematic. So, so especially think of kind of high-stakes decisions, so loans or the medical domain, and so on. So again, the model is sometimes going to be doing something else from what you're inferring from the explanations, right? So that's one problem. Another problem has to do with again, how much or how well it's going to generalize, because it's learned something, it does well on your you do your cross-validation, and it does well. But maybe your data has a lot of issues that are only going kind of going to pop up when you actually say deploy your model, you get new data, and you realize that your data that you had, say, wasn't really representative or had other issues. So in a way, if you can really kind of look into the model understanding, it's a way to further kind of validate it, or to kind of assess it a bit more, right? With the black box, well, you just kind of look at the score, you have this approximate measures, and you just kind of, well, believe this is going to work and go ahead. So, of course, if you have a lot of data and the data is clean and everything is nice, fine. The thing is that in real life, that's not really, it's very rarely the case. So, of course, in, I don't know, in image and text, you can get a lot of data and images with good labels, and that's fine, perfect. But again, let's if we think about tabular data or like domains like medical and so on. There's a myriad of different problems that you have from confounding, which I'm going to say a bit about, to selection bias, to fairness, possible fairness issues, to wrong labels, to you name it. So, so actually, when you have such kind of messy and problematic data, and let's say that is, I mean, I think it's kind of safe to say that there isn't that much of a difference between, say, some simpler models and say more elaborate ones. So, so regarding the confounding, I'm just going to tell you kind of about a small example. So this is related to the pneumonia example from before. So this was actually, as I said, a large study. And they wanted to do a clinical trial to really deploy a machine learning model and to see whether a person with pneumonia should go into the hospital or not. So that's kind of important, not just because of cost, but it's also dangerous to put someone in a hospital because there can be viruses. We kind of care about that decision. And so they trained a lot of models on those data that I showed you before. And the best one was a neural network, quite better than the other ones. But they didn't use it. They used the logistic regression. And the reason is that, for example, they saw it in logistic regression, they saw it in sort of a rule-based model, that there was this one particular rule when the model said, well, if the person has asthma or a history of asthma, then that person has lower risk, meaning I'm not going to send that person to the hospital. And that's exactly the opposite of what you want, and the opposite of what doctors do, because if a person with pneumonia has a history of asthma, they tend to send them to intensive care. By sending them to intensive care, they get a very different treatment. They get a treatment that actually boosts kind of their chances, and they end up kind of getting well in most of the cases. So that's the associations that's in your data. You see that the asthmatic people fare better, but you don't see why. It's the why is because they have been treated differently, and the treatment is getting confounded with the outcome. And again, you cannot use the treatment because you want to use the model before. So there's no way you can use this variable to kind of fix. So okay, you could fix the neural network and do it, but that's not the problem. The problem is like, well, what else is there? So maybe it's learned something else that in this, and this is a high stakes application, can be very problematic. So for example, it's a similar thing with pregnant women. They also receive this kind of same more aggressive treatment where they're sent to the intensive care. So you can also have such an association, and the model is going to pick it up. So, well, that's kind of what you get right with a black box. So there's many examples of confounding, which I guess many of you are familiar with, where the model is learning something that you don't really want it to learn, right? And for example, in the context of fairness, or something, you can see you have a zip code, which can actually be a proxy for kind of more sensitive attributes of a feature, and so on. So, so that's as far as kind of the black boxes. So, glass boxes as sort of the opposite. So, what are there? So roughly, that's a model that's kind of constrained in a way that we can understand what it does. So that's a kind of a very vague definition, but roughly, yeah, we'll give a couple of examples. That's kind of, let's see what they are. So we don't need to use kind of additional or external explanation. So the model is kind of able to tell us what it's doing. So there's many different names for this. So transparent, intelligible, interpretable, and so on. So I'll just use the term glass box. And the actual models that we have here are not fancy. They're really kind of old school, but there's some kind of new twists on that, which I'm going to mention a bit. So we can have models which are basically rules, such as decision trees or decision lists and sets. There's additive models, and you can have something less flexible, such as a linear model. But then you can add the interactions in the linear model, in the additive. There's a couple of things. There's like example of kind of custom models as well, such as the neural net that we see before, and so on. So one model that I said I was going to talk a bit more was the additive model. So in the additive model, so if we look at the right-hand side, we see that we have kind of, well, it's the sum, right? That's why it's called additive. And we have a function for each feature. So we have this univariate functions. And these functions are, well, kind of flexible. So there's nothing there. So typically there's no constraints specified. They're typically not parametric. And that's kind of what we get. So these are called typically shaped functions. So for example, in the classification case, so binary, which is I'm going to use, the sum only in the right-hand side kind of gives you the log odds. So if it's 0, then you're kind of in between the classes. So it's kind of, and if it's positive, the positive class has more probability and so on. So this is kind of one, for example, shape function. So here you can see, you can, well, kind of look at the relation between this variable and sort of what your target is, or kind of the probability of a person dying of pneumonia in this case. So this is kind of something that you can interpret, right? So there's if the value for a particular kind of, let's say, for someone who has 90 years old is very positive, it's going to increase the probability of the positive class, and this is going to decrease. So this is interpreted with respect to the baseline. So if you predict a 0 at a certain shape function, that means the prediction stays at the baseline, which for binary classification is simply predicting the say the probability, the prime probability of the majority class. And meaning that, for example, if you're somewhere around the 0, you kind of have the average probability of dying in your population. Only after 70, you have kind of a higher probability of dying from pneumonia than the average, right? In the data set. So we have a lot of these graphs, one per feature. You center them vertically, so you have the mean prediction is 0 over all the features. So that's then you have them on the same, the y-axis are on the same scale. So you can also visually compare a bit and kind of get a sense of which one is more, say, informative. So the further away from 0 the function is most of the time, the more information is telling. And you can also have interactions. So you can now have these terms where you have these two variable functions, so two variables, and you can interpret that by, well, heat maps. So so this is an example here. It's a bit of a, say, not very, I'd like to put a different example, but the one I have. So the probability of death, as we've seen, of pneumonia goes up with age, but that's actually different if the person has already had cancer. So if the person has already had cancer, it's the other way around. So the highest probabilities are the youngest people, and that has to do with childhood cancers, their kind of probability of, but again, bit more flexibility that you add to the model, so it can have this interaction. So further, more than two-way interactions is, well, you cannot really visualize this nicely. So, I mean, these models are, as we said, old school, you know them, but there's some kind of newer algorithms that perhaps you're not familiar with. So, for example, I also mentioned decision trees. So we typically train them with greedy algorithms, such as CART, and a part of kind of the reason why sometimes trees are not the best performing model is not the actual representation of the tree, but the algorithm that we use to learn it. Of course, learning the optimal tree is empty hard, so we cannot solve it optimally. But there's some kind of relatively recent work in that direction. So for not too large data sets, meaning you don't have too many variables, you can get decent, you can get kind of the optimal tree in terms of performance plus some sparsity penalty. So for example, on this synthetic data, this is a card tree, and this is a tree learned with, well, say globally optimal with respect to the score. And the globally optimized, of course, sparser, which is nicer for interpretability and actually performs better. So there's more to it than, say, just card. Also for GANs, for the additive models, so there's what I've just shown you before. This is trained with Actually, the training is based on decision trees. It's a bit kind of convoluted how it happens, but in the end, actually, what it does is basically a very fine-grained discretization of the feature. That's what it's learning. It's learning the discretization. But there's other ways to do it with spline, so we get something kind of smooth function. But there's actually ways to train these functions with neural nets. So you can have like neural nets that basically a function of a single feature, but they can have pairs when you kind of have a lot of feature neurons and whatever number of pairs you want. So that's another way to train this. And of course, there's many of them. So for a linear model or a classifier, there's not just one way to train it. Of course, it's not just logistic regression. There's from SVM or to using some kind of regularization or whatever. So there's different ways to do it. And finally, some ways you can improve these models. For example, you can do transformations. So the same idea from the example on credit scoring. So if you try a bit harder, you can often get more out of a simple model. So if you discretize, say, features and use a linear model, you can again have interpretability and a nonlinear relationship actually. And as I said, that's what that variant of additive model does. Or you can again add to feature engineering and so on. So this is one example of using an additive model to kind of really fix in a way something. So as I said, data comes with problems. So this is again from a medical domain. So this is one particular feature, and this was again a mortality risk. So this looks as the doctors expected, but there is this block here, which is completely kind of strange. So the data set is not that small. It's not just kind of a random fluctuation. There's something here. So it turns out that this value here is the mean value of this variable. So the data was incomplete and it got imputed by the mean. No, the problem here is that this is a value which is already in a quite risky area. So most of the people are actually over here. They have kind of better values of this variable. They're not at risk. But probably we cannot see the distribution of this variable, but probably it's very skewed. So the mean kind of goes a bit far away from where most of the data is, so it's not representative, and it's in the area where the not healthy people are. So you get something like this there. So you can, if you have a black box, you don't even see this, and with something like this, you can actually see, and pretty much, I think always you're going to see something that may disturb you, right? That you want to do something about. So I'm jumping a bit ahead. But one thing that you can do here is actually change the function. You can simply kind of use your domain knowledge and say, okay, this should be straight. I'm just going to kind of interpolate here and assume this has to be like that. You can easily modify the model and just kind of continue. And of course, interpretation of this, I already talked about it, so you can try it can lead you to discover something, right? As long as you have enough data. And so here we have some kind of error bars. And of course, I haven't said where did we get that from, but this is actually where most of the data is. Like most of the people are around 70. So the bars are tighter here. And there we have some couple of jumps. So you can kind of hypothesize, well, there's a jump around 67, and that's the age of retirement, so and so on. So maybe you've discovered something, right? If well, you have enough data. This, as I said, was like 14,000 patients. So maybe there is something really there like that happens, like the change in lifestyle and so on, and retirement that affects the risk. So you also might want to apply domain knowledge, and that's something you can do with an interpretable model. So for example, you might want to enforce monotonicity. So you might want to say, okay, the risk cannot decrease with age, or in a loan, it cannot, it can only be monotonic with respect to, I don't know, the number of successful trades or something like this. If you train your model, well, the PSG functions are not unlikely to come back by monotonous. In some area where you have not much data, there can be someone who has a different value, it can go down and so on. So you might want to enforce that. And kind of the way to do that is to do it after training. So if you do it during training, if there's a correlated feature, actually the model is going to compensate by changing the shape function of that feature. So your function is going to be monotonic, but the other one is going to change. So for the end, at the end, for those people, as age starts to grow, your shape function is always going to grow, but the other one is going to go so much down, it's going to again compensate. So you can do it again post-training. So just like I said before, you can kind of draw and change it. So of course, this will get you a model that does worse on your data than the one that you got from training. So when training, you optimize. But again, there's knowledge that you have that you might want to kind of prioritize over the data. Because you said data have a lot of issues, and then here you can combine easily your knowledge with the model, right, or kind of incorporate it. And yeah, that's kind of what you can do. Also in the asthma, the additive model learned the same thing. That if you have asthma, so this is discrete, say 0 and 1. If you have asthma, the risk goes down. Again, you can kind of change that function. So in summary, I'll talk a bit about models. So there's, as I said, these are kind of old school models, but they're recent, modern twist, as I said, to this, some learning algorithms that may do a bit better than the ones that you might have used. They can usually kind of be helped with careful preprocessing. For example, they often come relatively close to the black box. Maybe you can think if that the difference is going to actually materialize when you go kind of deploy your model, and maybe again, if your training data wasn't great, maybe that difference isn't actually necessarily going to materialize. And yeah, as we said, easier to combine with domain knowledge and suitable for high-stakes decisions. And again, people typically just go to the black box, but you can also have this in mind as well. And I wanted to kind of show you, since in the title of the talk was this intepretable package, and I haven't said a thing about it. There's different tools you can use for this. So this is one Python libraries from Microsoft. And you have here an implementation, for example, of this, it's called explainable boosting machine. It's an additive model trained basically with ensembles of trees. So each of these discretizations is learned from an ensemble of trees, which are then kind of condensed into this discretization. So kind of how it looks is that, well, this is a data set for predicting whether someone is earning more than $50,000 or not, based on, say, socio-demographic data. So if you look at this, you have your features here, and they're sorted. There's a simple way to compute which tend to contribute more to the target than others. So marital status is the one that's contributing more. So say divorce, married, then the age, then the capital gain. And then you can go at these and look at their functions. For example, if we look at marital status is categorical. So if the person is divorced, the kind of probability of earning more than 50,000 goes down with respect to the baseline. And for capital gain, which is how much they earn from other sources, for example, we have something like this. So this is an example where you might want a monotonic relationship, perhaps, to make sense. And also there's other issues. So for example, most of the data is here. So whatever you estimate here is, well, questionable, for example, but at least you can see what's going on, right? And decide whether you trust it or not, whether you like it or not. And then again, if you look at the individual instances, you can see how their predictions are computed. So for the first instance in the data set, it's a negative instance and the model is correctly predicting, and we can see why, right? So the baseline is, the majority class is the negative, so the intercept and the baseline is kind of sending us in that direction. Also the marital status, and the only kind of ones saying kind of the contrary are these few. So we can understand also at the level of the individual prediction. And okay, in the library you have more functionalities as well. if you're interested. So that's it for the talk. Thank you very much.
Thank you. It was really interesting. I'm lacking some details on actually how you can enforce monotonic relations afterwards. Because what I understood, I'm not seeing from the note, is that, for example, you can have these univariate functions on the underlying univariate functions being, for example, trees, right? So how can you enforce afterwards like these relations, especially attending to the underlying function?
Yeah, so if we're doing it after training, we've forgotten about the trees. So the trees that were there where this was trained are thrown away. So when you actually, well, when you say use the model, the trees, because I skipped that part completely. What you do is, in a sense, you're going to discretize your variable in usually many intervals. And for each interval, you're going to find the prediction of the ensemble of trees. And that's going to be the value of the function for that interval. So it's a very fine-grained discretization with this kind of piecewise constant function. And that's what you can change then. So you can change. So I don't actually, there's methods even when you're training to enforce monotonicity. I don't know internally how it's done here, but in any case, it's you don't have the trees at that point. They're gone. Next.
Yeah, I just wanted to ask that at least for large tabular data sets, in my own experience, I have found examples to provide like a good performance and supply values to provide both good local explainability as well as global explainability. So what's your opinion on that? How does that compare to this type of things that you have explained?
Yeah, I agree that typically boosting example is probably what's most likely to work best. So one of the things, for example, that based on trees, you don't need to do any monotone transformations of the data, and it just has to work best. And as far as sample values, again, you can get an idea. I think that kind of point on Glassbox was, in a way, in a sense, when, for example, in this high-stakes decision where you're not really, or you don't want to, or cannot afford kind of an approximate explanation. Of course, sample can get you an idea. You might get an idea like which variables are important or which are not. So that's one thing. Another thing is like this discovery of, right? For example, the drop that we saw in that shape function for the imputation, or simply interpreting or having this function right from. So, of course, you have many other ways to finding some kind of like partial dependence plots, but again, it depends on the independence assumption and so on. So, yes, of course, those things are, again, boosting typically is what's best in terms of accuracy, but that's not the entire story. That's kind of my point here. Welcome.
Any more questions? Yes. Well, thank you very much. Oya.
Okay, thank you.
All right. So that's the end. Before I talk about this very important slide, we're giving away free PyCharm licenses. Who would like a free PyCharm license? there's only one person, then you get a free Python license. Congratulations. Oprah Winfrey meme, mandatory reference. Yeah, we have more Python licenses than people who want a Python license. So please come to us, tell to your friends, tell your mom, tell everybody. Now, well, again, thank you everybody for coming here, to our presenters and our hosts. If you want to collaborate with PyData Metric in the future, there's a few ways you can do that. You can spread the word on social media. If you liked the event, then post it on Blue Sky. If you disliked the event, please post it on X. You can also give a talk. We have a permanent call for proposals open. This is the URL, but if you forget about it, don't worry, just talk to us. Beginner's talk and advanced talk, anything goes. You can also help us reach out to potential speakers or propose a topic, even if it's not you talking about that. If your company has a venue, maybe not as nice as this one, but with chairs and a screen and good audio and all of those things, please let us know as well. And if you are also willing to sponsor some food afterwards, that's even better, but please no pineapple on pizza, that's the only rule. So we're going to the upper floor now to continue the discussion. And if there's still appetite for more after that, then we're going to a restaurant that I didn't write the name for, but it's very close. Miguel, can you help me on this one? It's 2 minutes away from here, actually. So it's very, very close. I will look it up real quick. Yeah, Restaurante Vivei. So very close to you. And that is it. Thank you very much and see you next time.